Welcome to Brian's Logic Lab. Today we're going to work on a water heater circuit board. The board's about $300 if it's got to be replaced, but I believe we have a good chance of reviving it. Again, this video is for entertainment, and if you don't feel comfortable making these type of repairs, please bring in a pro. If you do decide to do these type of repairs, remember to turn off the power, the gas to the appliance before removing the circuit board. And at this point, go ahead and grab you a cup of coffee or your favorite drink. Sit back, enjoy the video, and if you have any questions or comments in the end, please leave them and I'll answer them. So at this point, let's jump into the video. What we're looking at here is a Precision Temperature 9049F control board. It's from a 550 EC tankless water heater. New, these boards cost about $300, but due to an accidental short circuit, this one's literally toast. The owner thought he killed it, but today we're going to see if we can perform some circuit board surgery to save it and get the hot water running again. The 550 EC is a workhorse for RVs and off-grid setups, but it's sensitive. When the owner accidentally shorted the 12-volt power directly to the frame, the main power trace acted like a fuse and it vaporized. In this video, I'm going to show you how to clean up the carbon tracks, restore the traces using the correct size jumpers. Then in the end, we'll perform some voltage checks to make sure everything's working correctly. So let's jump into it. Okay, the first thing we want to do here is do an inspection of the board. So I have it under the microscope and I'm just going from top to bottom, just looking for any damage or anything that doesn't look correct, bad solder joints, physical damage, that type of thing. So now I'm looking at the back side of the board just to see what I can see there. I'd like to do an initial inspection before we do any other measurements. Whoa, what do we have here? I think we have found the problem. So talking to the owner of this board, they accidentally shorted the power rail, or they shorted something out when they was working on it, so they caused this. So and they asked if if I could help them get this repaired. This board costs about $300. So you can see here the copper trace was basically vaporized off the board. So we will do our best to restore and test this board. So first, what I'm going to do is clean the board. So here I'm using an ultrasonic toothbrush with 99% alcohol. Works really good for cleaning. Haven't seen anybody else use a ultrasonic toothbrush for cleaning. Seen ultrasonic cleaners and other stuff, but the ultrasonic toothbrush works really well here. So that's what you're seeing me do right here. Alright, once I get most of the board cleaned, I just go back with a cotton swab or Q-tip. Just do a little bit of additional cleaning. You can see that the board where the trace was, it got hot. Obviously it burnt the board a little bit. You can see their fiberglass weave in the board. So here I'm just going to pull the copper trace back. I'm not going to try to reuse that. I'm just going to remove the damaged section and go back with a 22 gauge copper wire. So here's the wire that I'm talking about. It's basically, you see the red varnish on there. It's used in like transformers and solenoids. So basically, if you take some solder and work it a little bit with the solder is just transferring the heat to the wire, you can see that the red varnish, you can basically melt it off there, and when the wire turns silver, you know that it's taken solder and you removed that varnish. So here I'm connecting the the jumper wire back to the other side of the pin. The other side of the board has the pin that comes through here. So I'm just soldering it back to this connection, putting a little bit of flux on here. Flux helps with the flow of solder. It makes a huge difference, especially when you're working with smaller stuff. It's maybe not as important with large electronics, but when you're working with smaller electronics, it makes a real big difference. You get some nice, real nice, shiny, solid solder joints. So here I'm just going to form the wire. I'm going to follow the instead of the yellow brick road, I'm going to follow the charred road. So I'm just going to take a pair of tweezers and put it in the corner here, just to give it something to bend the wire around and create a radius. So you'll see me bend the wire here. So then I'm going to do the same thing to bend it the other way, sort of like a Z, I guess. Or so here the wire is bent, and now I'm just soldering it back to the board. So instead of just going to that one pin, I decided to take it all the way back to the large pad there. So here I'm just using a grinding tool to remove the conformable coating off of the copper, to expose the copper. Then I'll just take a Q-tip with a little 99% alcohol, remove the debris, and then clean it up a little bit more. I wanted to make it flat across the bottom, if you will. Didn't really have to, but just like to clean it up. Here I'm adding a little bit of flux. It's really going to help that take the solder. So here I'm just going to form the wire, bend it into place, add some more heat and solder. The heat will remove the red varnish. Here I'm using the ultrasonic toothbrush to clean up this side of the repair. So that trace was also burnt. It was like a T, so it comes down as well. So you can see where I'm adding another piece of the jumper wire, 22 gauge, to connect the trace back into that main connection that I just ran. Okay, here I'm just running the wire. I'm pushing it up under the other one just for added support. Then I'm going to solder those two together. First I'm going to tack in the bottom to help hold it, and then I can position the top just a little bit straighter and solder it into place. Before that, I'm going to go ahead and clip off the extra wire, the extra length. Remove it with a pair of tweezers. Touch up the solder joint, and now I will solder the T connection. Add flux as always; it really helps. Okay, as you can see, it come out with a very nice solder joint there on the T connector. Clean it with a little bit of alcohol on the Q-tip. So you notice some of the little green spots and stuff on the board, and what that is before I was attempted to cover the black charred spot with UV mask, and I ended up cleaning that off mostly. It didn't work as the way I wanted it to, so you can see some remnants left there on the board, but it doesn't hurt anything. It's that extra green is just UV mask where I was going down a different path and then backed up, so I didn't want to bore everybody with that part of the video. So what you see me just do there was take the grinding pin, take a little bit of the UV mask off of the copper trace, because that trace also needs to be repaired. Here's a much smaller wire that I'm just going to solder into place. I'm just matching the size of the trace basically the best I can. This is just a signal wire here, so it just needs a connection. It's not really flowing any current like the red one. The red one there, it needs to be substantial because it's a main power rail. So here I'm just soldering into place, touching it up a little bit. If you've never done this type of work, I really enjoy it. It's very relaxing for me. Here I'm just taking an X-Acto knife and trimming that wire. Take a pair of tweezers and remove that out of the way. So if you've never worked under the microscope, I mean, everything looks huge. Everything's really small here. Maybe in some upcoming videos I'll put something in the video for a size comparison, but I think you can tell, like, that's a Q-tip there, and you can see how huge it looks. So we're working with very small stuff here, but I view this as like the microscopic world. Just like you can go underwater, you can go out in outer space. This is another world. This is the microscopic world, and I love being in the microscopic world. It really relaxes me, and it allows me to focus, and I enjoy this type of work. So here I'm just using a little UV mask, put it on a drop on a X-Acto knife, and I got this is just a broke tweezer. You save your stuff when it breaks, or you can always repurpose equipment. So this is just a broke tweezer, and I'm using one side of it there. A few of these nicks here, they were caused by me when I was cleaning up the UV mask originally. So here, what I'm going to do is I'm going to use this. This is like a waterproof material. You can see the MG chemicals. That's pretty good stuff here. If you ever have something that's going to be around water or outside, this is some pretty good stuff here. So here I'm just going to brush it on the board on the repair, but actually I'm just going to brush it on the entire back side of this board just for additional protection. You can see the repair is not the prettiest in the world because of the the board is it's damaged, but it's not going to be an issue because the repair is solid, and it makes the board look like it's wet, but it dries really quick, and it's actually like a waterproof material. This brush that I'm using, it came with it. Hindsight, I should have threw that brush away. The hairs were coming out of it and everything. End up finishing with a different brush. I got a bunch of little brushes, but these brushes that came with two, they're not very good. It just leaves little hairs. You'll probably see some on the board here, but it's not a big deal. But I cleaned them out, threw the brushes away. Okay, we're at the point of the video that we need to verify the repairs that we made. So let's grab a multimeter, put it in continuity. When we have continuity, which means there's an electrical connection from point A to point B, we'll get a red screen, 0 on the reading and the sound that you hear. So let's look at the board. Just flip it over. Here's the repairs that we made. So let's check them. So this point here is the pin right here. So I'm going to take one probe, connect it to the pin, flip the board over. So I want to check it all the way from here to here, over here. So if I have continuity here, that means this whole line is good. There you can see it. So we verified that whole connection there. We also should verify, let me zoom in a little bit. Okay, you can see this line, it tees down to here. I don't want to check it here, I want to check it down here, and that'll verify all of this. So I'm going to check it right here. You can hear it, see it. The other connection that we want to verify is this one. So I need to switch my lead on this side of the board. That would be the same as this side of the resistor. So I'm going to put it on this side of the resistor, flip the board over. So now I'm checking this point. I'm going to check it over here. You can let me get a better connection on it. There we go. You can hear it and you can see the meters reading it. 0.1, that's the resistance of the meter leads. The last connection we want to check is on the other side of this resistor. So I'm going to put my lead there. Basically now we're checking this one. So it's this, it comes down, comes over, down, over, down, over, down to this middle pin here. You can hear it, see the meter. So all these have continuity. The last check that we'll do is we want to check to make sure that we're getting 5 volts out of this voltage regulator. If we're getting 5 volts here, the board should be fully functional. Then it'll be ready for a functional check. So I'm going to check the output of this voltage regulator. So I'm going to put 12 volts on this connector. So to show that, I've got the leads that will hook up to the board here. Put my meter on voltage. So I have a power supply over here to my right, but to prove it, you can see that I'm going to turn it on and we'll get 12 volts here. Okay, there's the 12 volts. I'm going to turn it off. I'm going to connect these leads up. The negative goes on the left pin. Positive goes on the right pin. Just like that. We'll sit the board back down. I'm going to take my black lead because I don't have 3 hands. I'm going to take the black lead and put it over here on the other side of this this common connection. So where it's hooked to my power supply, it's the same as this point here. That way I only have to hold 1 lead. So we'll put the negative in my power supply. Okay. Before I turn the power supply on, just because it's a little bit more difficult to do here, just to make sure that we don't short nothing out, I'm going to get a good connection on my red probe ahead of time, then I'll turn it on. So we're going to go ahead and check this pin right here. When I turn on the 12 volts, this meter here should read 5 volts if this voltage regulator is working correctly. So I'm going to turn the meter on. There's 12 volts coming in to here. This voltage regulator is putting out 5 volts. So, okay, I would deem this as a fix. Please, if you like this type of content, like the video, subscribe and share it. Please feel free to leave any comments below if you have any specific questions, and I'll answer the comments. Thank you.